everyone, welcome to the code walkthrough of inference with a pre-trained classifier. In this notebook, we'll explore how to use Hugging Face transformer-based model for zero-shot inference on text data using Keras NLP. We start with essential imports. Here we are using Keras NLP, a high-level NLP toolkit by Keras that integrates well with Hugging Face models and TensorFlow pipelines. The second step is model and preprocessor selection. The BERT-based an uncased preset loads a pre-trained BERT-based model and tokenizer. We're using BERT classifier configured with num classes 2 for binary classification. This allows us to perform sentiment-like classifications task out of the box. Now we give sample input. We provide two simple sentences, one positive and one negative, as test inputs. The preprocessor tokenizes the text, adds special tokens, and pads the model's required sequence length. Step 5 inference. This step performs forward inference with pre-trained classifier. The output logits represent the unnormalized class scores. The final output prints the softmax normalized probabilities for each input belonging to either of the two classes. While we haven't trained or fine-tuned this model, we can already provide meaningful predictions using pre-trained weights. We used a pre-trained bird model with Keras NLP, ran inference on two input sentences, and got predictions using a simple pipeline of preprocessor, model, and softmax. This is the code walkthrough for fine-tuning the pre-trained transformer. Using Keras NLP, we import Keras NLP for the model and pre-processing and TensorFlow datasets to load the built-in dataset IMDb in this case. We load the IMDb dataset, which is a standard binary sentiment classification dataset. Each example is a text review paired with a label 0 or 1. Define preprocessor and tokenizer. This loads the BERT tokenizer that matches the base uncased model, ensuring token IDs match the model's expected inputs. We map each text to a tokenized form, pairing it with the label. The result is patched and refetched for efficient training. From preset, which loads the pre-trained BERT model with a classification head on top. Num classes 2 sets it up for binary classification. We use parse categorical cross entropy as the loss. The output logits require from logits as true. Fine-tuning this runs one training epoch to fine-tune the BERT model on IMDb dataset. After training, we evaluate model performance on the test set, measuring accuracy and loss. This is a code walkthrough of build transformer from scratch. Using Keras, no pre-trained weights, no shortcut, just raw architecture and training on text classification task. We import TensorFlow, Keraslet, and TensorFlow datasets, our go-to toolset for building and training deep learning models. Same as before, we use IMDb dataset for sentiment classification. We define a text vectorization layer. We use text vectorization to tokenize and encode the input text as fixed length integer sequence. This handles pre-processing inside the model pipeline. We adapt the layer using training data. Text is now vectorized, that is tokenized and encoded. We batch and prefetch the performance. We define an encoder block which has multi-head self-attention, residual connections, and feed-forward layer and layer normalization. We build the full transformer model embedding layer that converts token IDs into vectors. Encoder block captures contextual information. Global average Boolean reduces sequence dimension, and dense layers map to final classification. We finally compile and train the model. Binary cross entropy for binary label tasks. Adam optimizer for stable training and accuracy for evaluation, and we test the model's generalization to unseen reviews.